Okay, so in this problem, we have a cylinder. It's trapped inside a right circular cone. So let's draw a little picture here first. So let's say we have a cone. And inside of this cone is trapped a cylinder. So inside of here I have a cylinder. Boop. Boop, 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 boop. And you can tell that my drawing skills are severely lacking. But you get the idea. So here's a cylinder inside of this cone. Okay, now we have some information here that we need to label. So we know that the cone has a height of 7. So that means that here the height is 7. The radius at the base is 5.5. So that means from the center to the end of the cone, this is 5.5. What are the dimensions of such a cylinder which has maximum volume? So we're trying to find the dimensions of this cylinder, and so that means that the cylinder, well, we need to label the characteristics of this cylinder. The cylinder has a radius as well. We can label it over down here, and the cylinder also has a certain height. Okay, so well, if you take a look at this, you'll notice, well, first of all, we need to write down the formula that we're trying to maximize. In this case, we're trying to find the maximum volume, so the formula that we're going to use is the volume of, since we're trying to maximize the cylinder, we need the formula of the volume of a cylinder. So the volume of a cylinder is simply pi r squared times h. Now this is a problem as usual. Nothing in this world that's worth doing is easy. We have two variables here, and we need to have it in terms of just one variable. So if you take a look back here at our information, well, you might have noticed that here we have two triangles. And you'll notice that these triangles are actually similar triangles. So if I put them down here, let me rewrite my triangles just down here. So this is going to be the big triangle, and then we have the small triangle. So the big one, the height of the big one is fixed at 7. That's this one right here. And the radius, the base of this triangle is 5.5, which is also fixed. Now the little triangle, you have to be a little bit careful. The height of the little triangle is this, which isn't exactly h. H is the height of the cylinder, but it is 7 minus h. That would give us this little chunk right here. Okay, and then the base of this little triangle is going to be r. Okay, so, well then that means that we can use our relationships with similar triangles to write one variable in terms of the other. Now, here you have a choice. You can solve for h, or you can solve for r, and well, it doesn't really matter. Let's set it up regardless. We can say that 7 over 5.5 is equal to 7 minus h over r. Okay, and so then why don't we solve for how about h? So if I solve for h, what I'm going to get is that h is equal to 7 minus I'm just going to round it up to two places, 1.27 r. If you multiply by r and then move over the 7. Okay, so let me circle this right here. So this is what h is equal to. And so I can go back here and plug it in. H is equal to 7 minus 1.27 r. Okay, so then I can get my new formula for the volume. Well, the volume is going to be 7 pi r squared minus 1.27 pi r cubed. Okay, and now here, this I can get the derivative of. The derivative of this function is simply 14 pi r minus 3 times 1.27. That's going to be 3.81 pi r squared. And I need to find, once I find my derivative, I need to find my critical points, right? Okay, so to find the critical points, we set it equal to 0, and we solve. We can factor out a pi and an r, so we would have 14 minus 3.81 r is equal to 0. And for this I get two solutions. I get that from this one I get r is equal to 0. From this one I get that r is approximately 3.67. Notice that though r can't really equal 0. The radius of my cylinder can't equal 0 because I'm talking about the volume of a cylinder, and a cylinder with a radius of 0 has no volume. You also can't make the cylinder really tall because, well, then it would have no radius, and you can also not squish the cylinder so much that you end up with basically no cylinder. So that's why this radius equals 0 makes no sense, and a height of 0 would also make no sense. Okay. So then, well, what I need to do is to make sure that this is actually a maximum volume kind of a situation. So I can do the first derivative test to check this out. Let me do my number line, and then I can put 3.67 here and test some easy values to test. Well, that would be 3 and 4. And remember that what you do is you plug these into the first derivative, which is right here. Okay, so if I plug in 3, I'm going to get 14 pi times 3 minus 3.81 pi times 3 squared. Okay. And if I do all this, I'm going to get that this is a positive number. Which means that this guy is increasing, as usual. And if I plug in 4, I'm going to get my 14 pi times 4 minus 3.81 pi times 4 squared, and this is going to equal a negative number, which means that my function is decreasing. And so that means that I have a maximum when the radius is equal to 3.67. So the radius equals 3.67 gives me maximum volume. Okay, so if the radius is 3.67, well, what's the height? Well, remember that I had this formula down here for the height, so I can just plug that into there to find my height. So if I do that, I'm going to get 7 minus 1.27 times, sorry about that, 3.67. And this is equal to 2.34. And that's it.